All right, last attempt, I promise. Sketch the region bounded by the graphs of the algebraic functions and find the area of the region. So I'm going to graph these two functions. Here's the first one, and here's the second one. The first one is just a shooting star. It is stretched. Actually, it shrunk horizontally, but I'm not too worried about that. It usually starts at 0, 0, but it does shift up 1. So I'm going to shift it up 1, and it's just a shooting star. This right here is a line. Crosses the y-axis at 1 and has a slope of 1. And what I want to do is I want to find the area enclosed by the two curves, or bounded by the two graphs, and it'd be the area right here. That's where it's actually enclosed off. So it's bounded by these two curves. And again, when you're finding the area between these two curves, what we're doing is we're finding the area under the top one. So imagine that area all the way to the x-axis. So when you do a definite integral, it finds the area under the curve to the x-axis. And if I take the area under that curve, and then I find the area under the bottom function, which is this line, which I'll represent here in blue. I'm just going to go ahead and do this fast. So the area under the top function, which is represented in red, minus the area under the bottom function, which is represented in blue, will leave me with this black stuff, which is what I'm after. I want to find the area enclosed by those two curves. So I'm going to take the definite integral, and it's going to be from here to here. So I need to first of all figure out where those two intersect. So I'm going to take the two functions, set them equal to each other. So I'm going to have the square root of 3x plus 1 equal to x plus 1. When I solve this, I'm going to get the x to one side, and I'm going to have to get rid of the square root. So let me first of all isolate the square root so I can square both sides. So I'm going to go ahead and subtract the 1 over. It's going to give me the square root of 3x equals x. So I got the root isolated. Now I can square both sides. So I'm going to have 3x is equal to x squared. That's going to give me x squared minus 3x equals 0. Factor out an x. And we're going to get x equals 0 and x equals 3. So I'm finding the area from 0 to 3, bounded by the two curves, so that's in that enclosed region, again, that black stuff. So when I do the definite integral, it's going to be the area from 0 to 3 of the top function, which is the square root of 3x plus 1, minus the bottom function, which was x plus 1. So top function minus bottom function dx. All right, now I'm going to simplify before I integrate. So the integral from 0 to 3 of the square root of 3x. The 1's will cancel after you distribute this negative. Okay, and then you have minus x dx. This is the square root of 3x, so I'm going to go ahead and have to do that kind of with u substitution, but I'm not going to really use u substitution. I'm going to look at that really as the integral from 0 to 3 of the square root of 3 times x to the 1/2, and then I can just treat that as a root. Minus x dx, and that was probably a big question a lot of people had. So when I integrate this, I'm going to add 1 back to the exponent. I'm going to come down here. So I'm going to have x to the 3/2. When I divide by the new exponent, I multiply by the reciprocal, so I'm going to get 2 root 3 over 3 minus 1/2 x squared, and then it's evaluated from 0 to 3. FTC, I'm going to plug in 3. This is going to end up giving me the square root of 3 to the 3rd power. So we have 2 root 3 over 3. The square root of 3 to the 3rd power is going to end up being, oh gosh, what's the square root of 3 to the 3rd power? It's going to be 3 root 3. So it's going to be 3 root 3 minus 3 squared is 9, so minus 9/2. There's my f of b minus my f of a. When you plug in 0, you're just going to get 0. That's pretty straightforward. Then root 3's are going to cancel. That gives you another 3. So we got 6 times 3 is 18/3 minus 9/2. That's going to give me 6 minus 9/2, which is 12/2 minus 9/2, which is 3/2. So there's my area bounded by the two curves. It ends up being 3/2. Last example I have here is, well, I'll have to come back and do this in the next video. This is going to take a little bit longer than I want it to take. So I'll come back and look at the next video at this example.